Hey everybody. So let's continue our LeetCode essential 75 questions combined. And today we're going to do a section of graph. So as I mentioned in the previous videos, I'm trying to distribute my sections into a variety of different topics, so that instead of focusing on one topic, I can get exposed to multiple sections, so that broaden my understanding about data structures and algorithm. So today we're going to do this question from a graph section called clone graph. So let's start. Okay, so as a starter, we're given a question. So there's a data structure node which has a value and a list of node which is called neighbors. I think it's very straightforward, and the goal is to just return a clone of this graph given the start node. So I know there are a bunch of introductory explanation, but I think it's very straight, simple. So anyway, as usual, goal setting is to return a copy node of the input node. What's the constraint? What are the constraints? First thing we need to consider no empty input. And so it seems it is possible. Empty node is possible. So that leads to edge case. Why don't we just write edge case right now? So if not node, we should just return none. Okay, so this is an edge case. Edge case. Great. So we're done with the edge case. So what else do we need to care about? Is this undirected? And it seems, yes, this is undirected graph. So graph has directed graph and undirected graph. And this question is undirected. In case of undirected graph, it means just two nodes are connected. So there is no, there's no direction from left to right or right to left. So basically, it's much simpler than directed graph. Okay, I think those are the main things that we need to care about, first of all. Okay, so node value is unique. Okay, this is a good point. So constraint 3, node value is unique. And there are no repeated edges. That's good. The graph is connected and all nodes can be visited starting from the given nodes. Okay. So let's do an example. So we're given, so I like to start with the example. We're given each index. So node 1, 2, 3, 4. Start index is, okay, I think we should also mention that start index is 1, just for my memory. So node 1 has connected graph of node 2, 4. Node 2, 4. I don't like the way it represents 2, 4 because it seems like integers, but in reality, neighbors is our list of node. So we need to be a little bit careful. So these are the nodes. Okay, and then node 2. So node 2 node 2 has connected to node 1 and node 3, and then node 3 is connected to node 2 and node 4, as in the picture, and then lastly, node 4 is connected to node 1 and 3. And yeah, so that's the input. Of course, we're given node 1 has value of 1, and then node 2 has a value of 2, and then etc. And then just continue to node 3 and 4 like this. But anyway, so we're given the node 1, and then we want to return. So first thing we need to create a copy node by declaration of node, and then node value in num. Num means the neighbor is none. So that's the way to create a node. Then we need to so we need to create neighbor nodes, then append to copy, then return copy. So one thing we can do is, so as an idea, is that this is a graph. So we can use BFS to traverse each node, and another combination, not just traverse, but we can use hash map, or in Python we can say dictionary, to create a mapping of original node and a copy node, and then a copy node has a value and neighbors, which is a list of node. So something like that. So this is really a data structure that what we wanted. And then in the end, we're going to return this. Let's name it visit of original node. And then if we return, then the answer is this is a map. So we're going to be returning copy node, including the value and the neighbors. Okay. So what are the to-dos? So to-do one is to create queue, traverse queue, and then to-do two is to so while queue exists, we're gonna pop the node, let's say original node, so we're going to pop the original, and then queue.pop left. I started kind of writing, but the idea is to create a copy node, if not visited yet, maybe let's say 2.1, and then as to do 2.2, we're going to create for each neighbors. So for each neighbors, we're going to create a node if not visited yet. So the goal is to append neighbors to the node, not the original node, but copy node. Yeah, so that's the point. And then lastly, as to do 3, we're going to append to the queue to continue. So that's the logic. What's the runtime? So runtime should be open because we only traverse once, each node at most once. And then memory usage should be also open because the length of queue is open and the size of hash map is also open. So yeah, I think these are the optimal solutions. Nothing can beat these in my understanding. So let's do it to do 1. So anyway, we need to start creating the visited node, not the node, but visited hash map, and then visited input node should be added. So we're gonna create node, and then value equals to node value, and the neighbors are still none, and then we also gonna create queue as Python's dequeue. We also need to append to the queue the node. So that's the logic, and then so that's the to do 1, and then to do 2, we're going to traverse. So while queue exists, while queue is not empty, we need to pop the original, and then so if this original node is not visited yet, not visited list visited hash map, and we need to create. Okay, so visited of original is the node, and then value is the original. Okay, so now we're going to create append neighbors to the copied. So for neighbor, which is the node in original node of neighbors. Okay, so first we need to create a node if not exists yet. So if neighbor not in visited, so we need to first make a bars of this node to continue. So visited of the neighbor nodes is the node. So we're going to create a node of this neighbor node of the value, and the neighbor is known. Okay, so we have created a neighbors, and then we need to append finally. Sorry, not the queue, but we need to append neighbors to the copy node. Okay. So what have I done? So I created the node. So far we have, at this moment, we created a node 1, and it should be so this node should have 2 and 4, and for neighbor, in neighbor, we created 2 and 4, but these are not connected yet. So we need to connect 2 to the 1. So this is what we're going to do. Okay. So now we have these, and so we need to call this visited again. So visit original node of neighbors. So now we are pointing to this node. Okay. So neighbors, which is the list. So we can use append. And what are we going to append? We're going to append the neighbors, right? So now we have this visited of the neighbors for each neighbor node. So we're going to call the node in the visited, so visited hash map of the neighbor node in each for loop. So this is what we done. So in first loop we have appended 2, and then in the second loop, in the second call of loop, now we have appended 4 to the neighbors. So now we have 1, 2, 4. Okay, so are we done? No, we need to do the 2 to 3. So we need to append to the queue to continue. So when should I append the queue? So my guess is that we don't want to repeat the cycle. So point is that if we just keep appending 2 and 4 in each loop, we are going to end up infinite loop. So we want to append queue only when these new nodes are not visited yet. So actually we're going to append queue in this if statement. So we can append neighbor node to the queue. And so that's the 2 to 3. This is the 2 to 3. Okay, then we can return, we want to return what? Yeah, so we want to return the visited. From the visited, we can return the node. Okay. Oh, so this is a typo. So append. Okay. Okay, so this is accepted. And let's do submit. Okay, so it's not too fast. It's not too efficient of memory usage. But in theory, this is all when runtime, as you've seen, we only traversing one time. And the memory usage all when, because the length of queue depends on the length of nodes, and then the size of visit is also depends on number of node. So yeah, in theory, this is the optimal solution of O(n) runtime, O(n) memory usage. So actually, for the sake of understanding, more understanding, we can actually print out what's going on. So original node value. Let's see how the process is going on. So original node as a starter, we can see like this, and then in the neighbor we can check. So print neighbor node value, and then yeah. So let's see. Yeah, as you see, we started from 1, and then 1 pushed the 2 and 4 to the queue. So now we have 2 is popped as original node, and then next 4 is popped, and then lastly 3 is popped. So that's the flow. And then 1 has neighbor node 2 and 4, and then this original node 2 has 1 and 3. Okay, we can actually do more. So as a print, we can also print. So new node, we can say new node found. And what is the new node? So that's the neighbor node of value. Okay, so this is good. So we can start with 1, and then node 2 and node 4 are new node. So these are found and appended to the queue. But at the node 1, when we found the neighborhoods of 1, it is not new. So 1 is skipped. But 3 is new. So 3 is appended to the queue. Let's see, 4. Node 4 already has 1 and 3. So there is no new node. And then similarly for 3, no new node. 2 and 4 are already visited. So for 4 and 3, they are kind of like skipped. So easily we can see what's going on in the background. Yeah, so that's pretty much it for this clone graph question. Thank you for watching. I'll see you in the next video.